In the name of Allah, who is the most gracious and the most merciful, welcome to the physics class. Today we are going to begin the new lesson, motion and force. In the previous lesson, we were dealing about kinematics. That was the branch of mechanics that was concerned with the motion of objects without the reference of force. Today we are going to begin with dynamics. It's another branch of mechanics that's concerned with the motion of objects in reference to the force. So today, force is important. So what is this force? A push, yes, maybe a pull, and a twist. These are the basic forces that we have studied in the earlier grades. Now, distortion means to bring a change in the original form. That's also through a force. But if you have to stop something that's moving, that also needs a force. Or if you want to move something that was originally stationary, again you need a force. So combine all this, we have a new definition of force. So we can say that it's an agent that produces or tends to produce motion in a body, or an agent which stops or tends to stop the motion of a body, or an agent which distorts or tends to distort the shape of a body to which the force is applied. We are using the word tend because it's not confirmed that there will be the movement when you apply the force, because it depends on the size of the object also. The Galileo was the scientist who worked on this, and he found that motion of a body continues along straight line unless some force causes it to change its state. But we don't observe it happening. Why not? Well, there are things like there is air resistance, there is force of friction, which are the things that resist the motion. So we don't have the ideal condition. So under the ideal condition, like if you're working in a vacuum, this is observed actually. Now observe what is happening over here. Be careful. There are 4 glasses. Over the glasses we have a tray. Over the tray 4 balls are suspended. The thing is that the balls are in the state of rest and they resist the change in their state. So when we remove the tray, the balls don't move with the tray because they want to resist the change in their state of motion. This is another example of a balloon popping. You have just taken in a slow motion that when you pop up the balloon, what happened? The water inside the balloon was in the state of rest and it resists the change, so it doesn't fall just altogether but took a little time. What is all this? This is actually inertia. All material objects have a property to resist any change in their state of rest or uniform motion. This property is named as inertia, as you can observe over here also, that the ball in the cart is resisting the change in the state. Similarly, we have been observing this when we are moving in the car or in the bus many times. When the car is moving, we are in the state of motion along with the body of the car. Just when the brakes are applied, suddenly, what happens? We feel a jerk forward because the body was in a state of motion. So when the brakes were applied, the lower portion of the body came to rest, that was in contact with the car. But the upper portion that was already in the state of motion resists the change. Due to inertia, it already stayed in the state of motion. So it took a while to stop and you feel the jerk forward. Similarly, when the car suddenly starts, we feel a jerk backward because we were in a state of rest. But when the car suddenly moved, the body resisted the change in the state, and so we feel a jerk backwards. These are the everyday observations.